Hello, welcome to Earth Science. I'm going to go ahead and share my screen here. We're going to take a look at today's lesson on atmosphere. This is going to be a little bit longer of a lesson, but we will get there. So go ahead and go into the weather and climate module, come down to today's date, click on atmosphere, and there's a couple of things you're going to do today. You're going to have bell work, which is up here at the top. You're going to take notes over some slides that are embedded. You're going to watch a video that's linked here. It's also embedded below. And then you are going to answer some questions in the homework assignment. So let's take a look at the homework assignment first. It is literally just a question set that you're going to answer here. So you're going to click here to make your own copy of the worksheet. You can go back to the lesson if you'd like to get some of these answers if you can't do it on your own. You can also Google if you need to. Make sure that you answer all of these questions. The last one down here, it's going to ask you to draw onto a picture. So in this blank blue space here, you're going to draw onto that. And there's instructions on how to do that right here in this brown type. So you're basically going to copy that picture into Google Drawings, make your drawing on top of it, and then copy it back onto this page in place of this one. So that is the homework. The next thing we're going to look at is the actual discussion post here. Excuse me. This is your bell work. You're going to do this prior to starting the unit. And it's not super long, it's not super hard. You're going to go into this bell work discussion post. You're going to talk about 3 things you already know about the atmosphere. Write those out in a post that's a reply to this one. And then once you have replied, you'll be able to see the responses that your classmates have made. And you're going to respond to at least one of them. So make sure you do both of those things for the bell work. All right, so let's get into the lesson itself. Bell work, we're going to take notes, and then we have a video to watch. So this image right here is just a sketch of the layers of the atmosphere. You have the Earth down here, and then the layers working your way out towards space. And then there's some little images in here of different things that happen in each of those layers. So this is going to make a little bit more sense to you after we go through the notes. You can come back and double check this again. But let's get through the atmosphere notes for now. The video that you're going to watch is down here at the bottom. It is embedded, or you can click here to watch it on YouTube if it's not loading in Canvas. But you'll do that after we finish the notes. We've got about 17 slides of notes today. Hopefully it will not take too terribly long for you, but go ahead and grab out whatever you're going to use to take notes with, on, or in. Pause me while you go get your supplies and then come back. All right, welcome back. Let's go ahead and dig into the atmosphere. So we're going to learn a couple of things today. You're going to be able to tell what the atmosphere is made of, how pressure and temperature change as you move away from the surface of the Earth, and what the layers of the atmosphere are. So this is a sketch of the layers of the atmosphere. You have these 4 main layers, and then the exosphere up here is going to be outer space. So we're going to talk about each of these layers individually. As we go through these, remember that you can pause the video at any point in time, come back to it, so you have time to finish up slides that you need to finish. For right now, you're going to pause the video and watch this short video from National Geographic. So go ahead and pause me, watch this video. It is linked in the slides presentation, and then come back. Okay, hopefully you enjoyed that quick video. What we're going to talk about now is what the atmosphere is made of. So for the atmosphere on Earth, an atmosphere is any kind of gaseous layer that surrounds either a planet or a moon. Not all planets and moons have atmospheres. Our moon doesn't have an atmosphere, but it's any kind of layer of gases that surrounds a celestial body. So for our atmosphere, we just call it air. It's the air that we breathe, okay? It's made up of mostly nitrogen and oxygen. There are a few other bits and pieces of things that are found in the atmosphere as well, but it is mostly nitrogen and oxygen. So you can see that it's just under 80%. It's 78% nitrogen, 21% oxygen, and then there's 1% of other stuff. And we'll talk about that other stuff in a minute. As you go through these notes, you'll have these red boxes show up that are some questions that you need to think about. Make sure that you're able to answer these or discuss these. These are fair game to be test questions, homework questions, and they're just important things to know. Everything on these slides are fair game for the test and the homework, so please don't only focus on the red boxes, but spend a little bit of extra time making sure you can do that. So this one's kind of a trick question. What fraction of the Earth's atmosphere is not made of nitrogen? Well, you're 78% nitrogen here and 21% oxygen here. Don't fall into the trap of saying 21% because it's oxygen. It's actually 22% because you have to add in that other slice as well. So 22% is not nitrogen. Make sure that you're reading these questions very carefully when you come through these. So what is our atmosphere made of? Some of that 1% is actually water. We have 78% nitrogen, 21% oxygen. In that 1%, there's all kinds of little bits and pieces of things, but it is mostly water. It can be water as droplets, as water vapor, as ice crystals. So some form of water is what most of that 1% is made of. The rest of that 1% is going to be things like dust and dirt that have come off of our continents, salt from the ocean, ash from volcanoes, all of the other little particles and crap that's in the air. So where do the gases in the atmosphere come from? There's a table right here that summarizes it up for you. So go ahead and look through that table. I would jot that table down in your notes so you know exactly what the gases are and where they come from, how they get into the atmosphere. So oxygen comes from the plants as they grow. When plants do photosynthesis, they take in carbon dioxide and they release oxygen. We're not supposed to have very much carbon dioxide in our atmosphere. It's part of that 1%. Carbon dioxide comes from animals breathing out. So when we breathe out the carbon dioxide byproduct as a result of cellular respiration, the plants take it in, do photosynthesis, and give us back oxygen in a cycle. It's not supposed to have huge amounts of this in the atmosphere. We do have ever increasing amounts though, because carbon dioxide can come from within the earth. If you have something like a volcanic eruption, it comes from when we breathe, when animals breathe, we give off carbon dioxide. It's also given off when we burn things that were organic at one time. So they came from plant or animal materials, decaying, dead, whatever. They were once a living organism. And that's going to be things like fossil fuels, coal, oil, even natural gas. We continuously burn these fossil fuels, and as we do that, we release carbon dioxide into the atmosphere. It is called pollution. It is only one type of pollution, though. And the more that we get, the more hangs out in the atmosphere. It ends up trapping heat from the sun. We get global warming, we get climate change, and it's a whole thing. It's a soapbox I'm going to try to not get on while we're in this lesson because we're going to have a climate change lesson coming up. Nitrogen is a big part of the atmosphere. That's that 78%. When organisms die, they decay, and as they decay, the nitrogen in their systems, the mineral in their system or element in their system decays, and it either goes back into the ground as a nutrient or it gets released into the atmosphere. The last one we talked about was water vapor. It can be any form. It can be evaporated water, that's water vapor. It can be liquid water droplets, particles. It can be solid particles, ice or sleet. It can be locked up in the clouds. It can be loose. But water vapor is the last one. So 2 gases that volcanoes contribute to the atmosphere. You should be able to come up with that based on this chart. Just look through this chart and see where it says volcanoes. Okay, I didn't talk about it initially, but the last one is right here, volcanic eruptions on water vapor. When you have a lake or a body of water and a volcano erupts in that vicinity, the heat from the volcano will instantly vaporize that water in that lake and put the water vapor up into the atmosphere. So that's your second one in addition to the carbon dioxide. So air pressure is going to change with height. Air pressure is how much the air above you weighs. And remember that weight is a basis of the total mass of whatever you're looking at, plus the pull of gravity on that mass. So it's actually the pull of gravity on the mass that causes the weight. And as it gets further and further away from the Earth, air weighs less and less because there's less and less gravity pulling on it. So in general, air pressure is going to be lower the further away from Earth you get. Normally, we're not going to notice these small changes in air pressure in each layer because our bodies are used to it. Air pressure is kind of normalized for us. When you have big changes in air pressure, like when you get in an airplane and go up, airplanes are going to fly up in this layer here, the stratosphere. Air pressure is less, so they have to equalize. They have to maintain the pressure inside the cabin. So it's less pressure outside than inside. So that's why they have those oxygen masks that fall down. So if there's some kind of accident where there's a hole in the cabin or something, general rule is things are going to move from high concentration to low concentration. Hopefully you remember that from biology class with cell transport. High to low takes no energy. It happens all on its own. So if you have high pressure inside the plane, low pressure outside the plane, you poke a hole in the plane, air is going to move out very, very quickly. They have oxygen masks come down so you can still breathe. Fun fact. Don't be afraid to fly. It almost never happens. All right, so the higher you go, the lower the pressure gets. So in this image here, try to take a look at it and see, explain what the difference is in the air pressure by the tree versus the air pressure by the plane. Okay, so we talked about the pull of gravity on air pressure and how that is why it changes as you get further away. Air can also get hotter and colder depending on what layer you are in, and that will also have an effect on the air pressure. So let's take a look at that. You have this line over here that's kind of zigzagged, and that is the temperature of each layer. So it's hotter down here on the surface of the Earth than it is at the top of the troposphere. As you move up through the stratosphere, it gets warmer again. Mesosphere, it's going to get colder up here, and then it gets hotter in the thermosphere. So this end over here is hot, this end over here is cold. So as air pressure is going to decrease in a roughly straight line all the way up, temperature can change a little bit, and it zigzags through our layers. Temperature does have a small effect on air pressure as well. So why does air temperature change based on the height or how far it is away from the surface of the Earth? Well, it depends on what gases are present in the atmosphere. Some of them will absorb heat or absorb energy. Some of them will reflect energy. And it depends on where you're at, what layer you're in. and what gases are there as to how warm or cold it is. So the 4 layers of the atmosphere that we're going to talk about, these are our main 4 layers. There are some minor layers with this as well. We'll talk about one of those, but we're really only going to worry about these 4 major layers. Troposphere, stratosphere, mesosphere, and thermosphere. And those are listed in order from closest to the Earth to furthest away. Outside of the thermosphere, you get outer space. And one thing to note about these is there's not a firm boundary. It's not like when you get from one to the next, you hit a ceiling and have a sudden change. They kind of blend into each other. So if you were to assign colors, if the troposphere is red and the stratosphere is white, the border here in between them would kind of be a pink area. If you're a mnemonic person, you can use tacos sound mighty tasty. I am not a huge fan of mnemonics with this one because the first and the last actually have the same letter to start with. For 4 things, it's just easier to memorize it. If you know them in order one way, you can recite them in order the other way as well. So looking at this image, you should be able to tell where the border between the mesosphere and thermosphere is at. So this is your altitude over here on the left. So figure out where that border is. All right, let's talk about the troposphere specifically. This is the area of the atmosphere, or the layer of the atmosphere that we actually live in. It's right here down on the surface of the Earth. This is where most of our water vapor, carbon dioxide pollution, and living things on Earth exist. We are terrible about putting pollution up there. It's not supposed to be in the atmosphere. And remember, we're only supposed to have minimal levels of carbon dioxide. Much lower than what we have because of our industrialization, our vehicles that put off exhaust, which is carbon dioxide, all of that. The big thing that you need to take away from this is the troposphere is where we live, where all living things are at, and it's where our weather takes place. So remember that climate is what we expect to happen, weather is what actually happens. So weather is going to be, is it sunny, is it rainy, is it storming? And all of that is determined based upon the conditions of the troposphere. This is our densest layer of the atmosphere. It's at the bottom, so all the other layers are kind of pushing down on it. So this is where 90% of our gases in the atmosphere are held. It has to be able to support the weight of all those other layers. As you move higher up, air temperature is going to decrease. Air pressure is also going to decrease because remember that as you get higher, pressure gets lower. This is why people that go to, say, drive to the top of a mountain, once they get above a certain threshold or a certain height, they start getting a little bit woozy. It's called altitude sickness, and it's because the air pressure is so much less up there that their body feels like they're not getting enough air. So think about why the troposphere is important to us, be able to discuss that. So taking a look at the stratosphere, as you go up from the ground level into the stratosphere, once you get into the stratosphere, the temperature is going to decrease. Once you hit about 15 kilometers, you're going to hit that stratosphere and the temperature is going to start to increase again. So as you go up through the stratosphere, it's going to get warmer again. So we're down here on Earth, we're on the surface, temperature is getting lower as we go through the troposphere. For roughly 15 kilometers-ish, give or take a few, it starts getting warmer again. That's that stratosphere layer. Strato means layer, so inside the stratosphere, there are actually layers of gases, and they don't mix together. So down here in the troposphere, all the gases are mixed together, mashed up, all intertwined. In the stratosphere, they kind of settle out and form their own little banding pattern there. There's one particular layer called the ozone. It's where 3 oxygen molecules are bonded together. This is kind of like our solar blanket around our planet, and it traps in a bunch of heat. It absorbs energy from the sun, and it's what helps regulate our temperature. So that helps keep things warm, and that's one of the reasons that the temperature gets warmer as you move up through the stratosphere, because you're getting towards that ozone where everything's getting absorbed. One of the things that the ozone does for us is it blocks out UV light from the sun. That is basically what makes the planet a place that we are able to live and survive. When we were dealing with massive holes in the ozone layer that have started healing now, we were getting way more ultraviolet light in some areas of the planet. It was allowing more of that heat and energy to come in, and it was actually causing health issues for people in those areas. So be able to discuss this question: why is ozone in the stratosphere important for living things? And I stopped sharing my screen. Let me get that back. There we go. Sorry about that. The mesosphere. So this is our next layer up. This is between the stratosphere and the thermosphere, and temperature is going to start going down again as we move further out. Up here in the mesosphere, you can get temperatures as low as negative 93 degrees Celsius. If you convert that and do the math, that's negative 135 degrees Fahrenheit. Thermosphere. For the thermosphere, this is the top layer of the atmosphere that we're going to talk about and we're going to focus on today. Temperature is going to rise again. They're going to start absorbing that energy from the sun again. Instead of allowing it through, it's going to hold it in. Sorry about that. So thermo means heat. This is going to get up to 1,000 degrees Celsius. So super hot, absorbing lots and lots of energy from the sun. The ionosphere is an extra layer. It's kind of there in between the mesosphere and the thermosphere. And it's called the ionosphere because it's made up of ions. Ions, remember from chemistry, are charged particles. And as the energy from the sun hits those particles, it bounces off of them and creates these really pretty lights. So some of the things that happen in the ionosphere that kind of help us out and make it important. This is where the radio waves are reflected back. So this is why we can communicate around the planet. So remember, this is one of the extra layers that's kind of in between the layers. And this is our last slide for the day. So once you're done with this, go ahead and close out this video, watch this one here from your lesson page, and then come down here, answer your questions, and you are done for the day. We will see you next time.